In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 31. Oil and gas productions, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization, lecture number 31. This is a recap of petrochemical part 2. Part 1 I have already discussed in my last lecture yesterday. Today I'm going to discuss my lecture number 31, but this is a part 2 for petrochemical. Okay, before my lecture I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatum min lisani yafqahu qawli Allahumma rabbi zidni ilma. O my Lord, open my chest and ease my task for me and loose a knot from my tongue that they may understand my sayings. Allahumma rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Okay, please send me your input or feedback. I have also provided my WhatsApp number and email address at the end of my presentation. Okay, oil and gas production. We have discussed introduction, facilities and process, reservoir and wellhead management systems, upstream facilities management system, midstream facilities management system, refining facilities, petrochemical facilities and management system, utility system. This is our next sections we are going to discuss next couple of weeks. And unconventional, conventional resources and environment effects. What is the ultimate goal? Ultimate goal, shaping the clean and sustainable global energy in the world by large. Planned to deliver more than 300 lakhs next couple of years. Okay, oil and gas production, lecture number 31. What we have planned to discuss first, we will discuss ethylene derivatives, propylene derivatives, butadienes, butylenes, gas derivatives, and synthesis gas. These are 4 sections we are going to recap what we had discussed earlier. Okay, key takeaway points, lecture number 31. Ethylenes, propylenes, butadienes, butylenes, gas, and derivatives. Okay, ethylene derivatives. This is a continuation from my yesterday lectures. If you can see here, first my olefins. So from olefins we have derived ethylenes, propylenes, butadienes, butylenes, and gas. Okay. Olefins are petrochemical derivatives produced by cracking a feedstock from raw materials such as natural gas and crude oil. Lower olefins have short chains with only a 2, 3, or 4 carbon atoms, and the simplest of one is the ethylene. The higher olefins have chains of up to 20 or more carbon atoms. The main olefins products are ethylenes, propylenes, butadienes, and C4 derivatives. They are used to produce a plastic as chemical intermediates and in some cases as industrial solvent. Okay, if we see over here the structure here, this is my ethylene, ethyl benzenes, alpha olefins, ethylenes oxides, and polyethylenes, and over here ethylenes dichlorine in place of chlorines. Okay, further it produced vinyl chloride and polyvinyl chloride over here, and the ethylenes are produced phenol here. So the ethylenes oxide are produced 2 products, ethanol amines, ethylenes glycols, and further it produces polyester fibers, resins, and polyester chains. Okay. Ethanol, also known as ethyl alcohol or common alcohol, is manufactured by synthesis from ethylene. It is an oxygenated hydrocarbon are used in a wide variety of high-performance solvent application. So it used in many places: toiletries, cosmetics, paints, liquors, thinners, printing, inks, dyes, detergents, disinfectant, and pharmaceuticals as a chemical raw material for the production of range of monomers and solvent, and is essential in pharmaceuticals or purifications. In transportation, ethanol is used as a vehicle fuel by itself, blended with gasoline or a gasoline octane enhancer and oxygenate. Ethanol amines are prepared by the reactions of ammonia and ethylene oxide. They include monoethanol amine (MEA), diethanol amine (DEA), and triethanol amine (TEA). The three are widely used in industry principle as absorbent for acidic components of natural gas and of the petroleum refinery gas streams. It is also used to make a detergent, Matchworks fluids, and as gas sweetening. Tea is used in detergents and cosmetic application and as cement additives. Then polyethylenes, a PE with world production around 80 million tons in the most common plastic and polymers. It is a polymers of ethylene, especially any of the various lightweight thermoplastic that are resistant to chemical and heat. Okay, many kinds of polyethylenes are known, with most having the chemical formula C2H4 H2. It has been many different trade varieties, and the most common are: first is the HDPE, high density polyethylenes, as discussed in my earlier lectures. Second is low density polyethylenes. Third is linear low density polyethylenes, LLDPE. Okay, first we will brief about HDPE. Is used predominantly in the manufacturing of globe molded bottles for milk and households, cleaners and injectional pails, bottles, caps, appliances, housing and toys, etc. Low density polyethylenes (LDPE) is used in film application and due to its toughness, flexibility, and relative transparency. Typical LDPE is used to manufacture flexible films such as those used for plastic retail bags. LDPE is also used to flexible lids and bottles in wire and cable application for the stable electrical properties and process characteristics. Number three, linear low density polyethylenes (LLDPE) is used in predominantly in the film application due to its toughness, flexibility, and relatively transparency. LLDPE is a preferred reason for injection molding because of its superior toughness. Last is a polyvinyl chloride (PVC). A polymer of the vinyl chloride is used to make a diverse range of cost-effective products with various level of technical performance suited to a wide range of application. Many of these PVC products are used every day and include everything from medical devices, products used such as medical tubing, blood bags, footwear, electrical cable, packaging, and stationery and toys, etc. Okay, now we're going to discuss propylene derivatives. In my earlier slide, we have discussed ethylene derivatives. Again, if you can see here the olefins here, so it will derive ethylenes, propylenes, butadienes, butylenes, and pgas, and propylene will process and propylenes oxides, acronitriles, polyethylenes, and cumins. So then it will further produce polyesters and polyurethanes here, or is also known as a foam, and then it will be acronitriles here and butadienes and polyacronitriles here. So the acetones will further produce MMA, methyl methacrylate over here, and phenol will produce a phenolic chain here. Okay, the propylene derivatives are polypropylenes, PP, are various plastics or fibers that are polymers of propylenes, and propylenes can be made into fibers where it is a major constituent of the fabrics for home furnishers such as upholstery and carpets, numerous industrial and end users including ropes and corries, disposable non-woven fabrics for the dampers, medical application, etc. As a plastic, propylene is molded into bottles for foods and personal care products, appliances, housing, dishwasher, proof food containers, toys, automobile, battery casing, and outdoor furniture, etc. Okay, polyurethanes are used to make the foams in the furniture, mattress, car seats, building installations, and coating for floors, furniture, and refrigerator. They are also used in artificial sports tracks, jogging shoes, and in the rollerblades wheel, etc. Okay. Further, Furthermore, polyacrylonitriles, a PAN, is a semi-crystalline polymerism, though it is a thermoplastic. It does not melt under normal condition. It degrades before melting. It is used to produce a large variety of products, including ultrafiltration membranes, hollow fibers for the reverse osmosis fibers for the textile, and applied fibers that are the chemical precursors of the carbon fibers. Cumin is aromatic derivatives from the benzene, and it is used in turn to produce the polycarbonates, phenolic resins, and essential healthcare products such as aspirin and penicillin. Next is a methyl methacrylate MMA. The principal application of MMA is the production of a polymethyl methacrylate PMMA. Acrylic plastic, also MMA, is used for the production of the copolymers, methyls, methacrylate, butadienes, stirred MBS used as a molder for the PVC MMA polymers, and copolymers are used for waterborne coatings such as latex, housing paint, etc. Okay, from the next slide, we'll discuss butadienes, butalennes, and pay-gas derivatives. Okay, this is continuing from my last slide. We're going to discuss butadienes, butalennes, pay-gas derivatives. Again, it is derives from the olefins, ethylenes, propylenes, butadienes, butylenes, and pay-gas. If you can see here, in places of propylenes and butadienes, it first is produced stern butadienes, polybutadienes, and number 3, polyisobutylenes. Okay, so in the butylenes, it will produce isobutylenes and polybutylenes over here, and further it will turn into the MTBE and MMA product. Okay, the pay gas or pyrolysis gasoline is naphtha range product with high aromatic content used either for gasoline blending or as a feedstock for BTX extraction unit. Pay-gas is produced in an ethylene plant that processes butane, naphtha, or gasoline. Okay, polybutadiene is a synthetic rubber that is a polymer formed from the polymerizations of the monomers 1,3-butadienes. It has high resistance to wear and is used especially in the manufacturing of the tires. It has also been used to coat or encapsulate electronic assemblies, offering extremely high electrical resistivity. Okay, next is the polyisobutylenes is a synthetic rubber or elastomers. It is a special because it is the only rubber that is gas impermeable. It is the only rubber which can hold air for a long period of time. Polyisobutylenes, sometimes called butyl rubber, is a vinyl polymer and is very similar to polyethylenes and propylene structure. Okay, next is a polybutylenes. PB1 is a high molecular weight, linear acetic and semi-crystalline polymer. BP1 replace material like metals, rubbers, and engineering polymers because of its specific properties. It is mainly used in pressure piping, flexible packaging, water heaters, compound, and hot water, etc. So that is a polybutalenes here. Okay, now we will next is the methyl terabutyl. MTB is used in gasoline to boost the octane rating and to decrease toxic emissions in the exhaust. As an octane enhancer, MTB delivers high octane numbers or relatively low cost. A direct effect of the use of MTB is the reduction of both regulated emissions, CO and unbound hydrocarbons, and unregulated emissions. Okay, so from the next slide, we will discuss synthesis gas. Okay, synthesis gas. Syngas is used for production of methanol or ammonia. It is also used for production of synthetic fuels, both diesel and gasoline. Okay, if we can see here, this is my synthesis gas. Through synthesis gas, we produce methanols and ammonia. Ammonia further produced urea. Through methanol, we produce formaldehyde and MTB and MMA and dimethyl terephthalate. And from the formaldehyde, melamine formaldehyde, urea formaldehyde, phenol formaldehyde, and last is the acetyl resins. Okay, now we'll discuss each product. First, methanol. Colorless alcohol is a chemical used in the production of formaldehyde, acetic acids, and methyl methacrylate MMA, and is used as a solvent in many applications. It is also used to produce MTB and other products and can be used in fuel. Second is melamine resins or melamine formaldehyde. Also incorrectly, melamine is hard thermosetting, a plastic material made from the melamines and formaldehyde by polymerization. This plastic is often used in kitchen utensils, plates, and amine constitute the high pressure laminates and laminate flooring. Number three is a urea formaldehyde is non-transparent thermosetting resins or a plastic made from urea and formaldehyde. It's used in the adhesive finishes, MDF, and molded object. Its attributes including high tensile strength, heat distortion temperature, low water absorptions, mold shrinkage, high surface hardness, and elevations at break. Number four is a phenol formaldehyde is a low cost basic resins. Addition of appropriate fillers can generate high temperature resistance grade 185 degrees C to 150 degrees C. Application including molding, bottle tops, resins, chemical resistance, coating for metals, laminates, water lubricants, bearing foams for a thermal insulation. Okay, next is a polyaxomethylene foams, also known as acetyl resins, polytraxenes, and polyformaldehyde. And formaldehyde is an engineering plastic used to make gears, bushing, and other mechanical parts. It is also known in the varying trade names such as Dalren, Celerons, and Hostoforms. It is the most important polystyrenes resins, are thermoplastic with good physical and processing properties. Last over here is methyl MMA. So in MMA, the dimethyl and then dimethyl terephthalate DMT is an acidic trifetalic acids, and methanol is used in production of polyester including polyethylenes terephthalate and polytriethylenes terephthalate. It consists of benzenes with methyl ester group attached. DMT has largely been replaced by pure terephthalic acid PTA as the powerful and industrial route to the polyester production. Okay, next is ammonia-based product. First is ammonia is a pungent, colorless, gaseous, alkalines compounds of nitrogen and hydrogen NH3 that is very soluble in water and can easily be condensed to liquid by cold and pressure. It is manufactured by the direct combination of hydrogen and nitrogen under pressure over a catalyst. The main process is still behavior synthesis invented in 1915, operating 1525 MPa and between 300 to 550 degrees Celsius in 4 reactions chamber with catalyst. The anhydrous ammonia is a main usually for the manufacturing of nitrogen fertilizer. It is also building block for the synthesis of many pharmaceuticals for explosive and used in many commercial cleaning products. Urea is a synthesis from the ammonia and carbon dioxide. It is named from its presence as human. Most land animals' urine, except fish and birds, dissolved in water. It is neither acidic nor alkaline. Urea is widely used in the fertilizer as a convenient source of nitrogen. Urea is also an important raw material for the chemical industry in animal feed, plastic, and resin, etc. This was my last slide. Okay. Today I'm going to conclude my lectures over here. Today we have discussed propylene's derivatives, butadienes, butylenes, pegas derivatives. Okay, my next topic we are going to discuss utility system. Okay, references Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation, Pakistan, World Energy Outlook 2030, US Geological Survey, US Department of Energy, Schellenberger's Oil Field Glossary, International Energy Agency, Wikipedia, Oklahoma State Margins, State Oil Fact Sheets, NORSEX Standard, The Story of Oil in Pennsylvania, Air Liquid Gas Encyclopedia, Natural Gas from the Wellhead to Burner Tip. Okay. Together, everyone achieve more. Please do not hesitate. Send me your input and feedback at t.masood.dear@path.edu. Thank you very much. Stay safe, stay at home, stay safe, inspired, and blessed. Please send me your input also WhatsApp. Through WhatsApp, I have provided my WhatsApp number. Thank you very much and stay blessed.